So today, I think we'll probably end up finishing Supplement B, and we'll just be done with this a day earlier than I had kind of thought I would take, because I'm not going to do this section 3. I'm just going to do a bare bones approach. I just want to be able to cover one idea that we need to do section 4. So there's not much to do in here. Okay. So what we're going to be talking about in section 3 is using a matrix to solve a system. Okay, so this is an example of a system of equations, right? We spent a whole chapter way back dealing with how to solve these guys, right? And way back then, we kind of talked about, like 3 methods to do this. We talked about graphing to find the intersection in a 2-dimensional system that's realistic. And then we talked about substitution and elimination that scale to bigger systems as well, but are perfectly effective in solving a small system like this. Everybody kind of remember that? We can also solve this same system using a matrix. So in order to do that, what I need to do is first I need to make sure that everything lines up vertically. So notice that the way I've written these 2 equations, I don't have a single variable in any column, right? The first column has x's and y's in it. The second column has y's and x's in it. The third column is fine because it's all constants. Everybody kind of see that? So the first thing I'd want to do is to rearrange this so that everything lines up. So now I have like a column for the x's, a column for the y's, an equal sign, and then a column for our constants or the solutions. Everybody's cool with that? What I do next is I'm going to translate this into a matrix. Not surprisingly, I hope this matrix that I'm going to create is going to be a 2x3. It's going to have 2 rows and 3 columns. Right? We have 2 equations, and we have like 3 different parts of each equation. Everybody kind of see that? Now, what I'm going to type into my matrix, though, is just going to be the coefficients. So no variables, no operations, just the coefficients. Everybody's okay with that. Now, again, I want to really emphasize that, like, the equal sign has to be kind of in this position. It has to be where the answers are on the right-hand side of your equation. When you convert this into a matrix, your system has to kind of be in that format where you have variable, 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 whatever, equal sign, and then constants. Has to be formatted that way, or this, what we're about to do, will not work. Everybody's cool, though? Okay. Now, there's a command on our calculator called RREF. What that stands for is row reduced echelon form. Not that that matters, but if you're curious as to what that, it's like, okay, there's some letters there. What the heck does that mean? Well, those are the words that it stands for. What the heck do those words mean? To give you like the briefest explanation possible, what that's really saying is in our calculator is programmed an algorithm. That algorithm is ostensibly the elimination algorithm that we used when we solved systems applied to these matrices. So it's going to take like, row 1, multiply it by -5/2, add it to row 2, store it to row 2. That's thus eliminating the x coefficient in row 2. And it just does this all internally. It's all programmed into your calculator. So let's go ahead and show you kind of what we end up with. So I'm going to just take matrix A. I'm going to change it to a 2x3. And I'm going to type in the matrix that we have written down on our paper. Everybody's cool? Going to exit out of the matrix menu. I'm going to go back in, but this time I'm going to go to the Math tab. I'm going to scroll all the way down to the bottom till I find that command RREF. Make sure that you're picking RREF and not REF. They are different things. They do slightly different operations. The one we're going to always use is RREF. And I'm going to do that on that matrix A that we just built. And just press enter. So that's our result. I forgot, was it -3 and 2? 3 and -2. Good thing I double checked. Pretty easy so far, right? Nothing really complicated. Calculator did the hard part. Guess what? That tells us our answer to the system. So if I look at the first row, and I remember how we translated our system into a matrix, I'm now going to translate our matrix back to a system. So if I look at that first row, that's one equation that says 1x plus 0y is equal to 3. Or really just that x is 3. If I look at that second row, it says 0x plus 1y is equal to -2. Or really just y is equal to -2. What do you guys think? Quite easy, right? You're just using your calculator. Why don't we try one more? I'm going to write down an example, give you a few minutes to try doing this with your calculator, see if you can get the solution to come out. And then we'll go over it together and then move on to the next stuffs. Yes. Yeah. One moment, or come on up and I'll have one for you. I just want to get this written down. You may have to stand here for like a moment. Sure thing, dude. So let's take a couple minutes, let you guys try this, and then we'll go through it as a group. You're welcome. I wrote up the answers there if you've gotten to the end and you wanted to check to see if you got the same thing. We'll go through it again as a group in real time here in a minute or two, but I still see people like fiddling with their calculators right now, which is great. Fiddle away. You know what I mean, guys? Yeah. All right, are you guys ready to kind of walk through this thing? All right. So initially, what was the one thing that you noticed, hopefully, in the very beginning that you're going to have to be careful about? that last equation doesn't have a y in it, right? That's not a big deal. I'm just going to assume that, I can just write it as a 0y there. Now everything lines up and it's in its proper place. So when I typed my matrix A, this is what I typed in. Everybody's cool with that? Notice the 0 there for the missing y. And then when I did RREF of A, I got this. The first row is x equals -4. Second row, y equals 2.5. And the third row, z equals -1.5. The RREF? Yeah. So you press second, and then the matrix button. You go to the math tab and scroll like all the way down to the bottom. Did you find it?
Okay, yeah, now I got it.
Okay.
Thank you.
No problem. When I was able to call it with just pressing things on my keyboard, it's because I had already used it, so I just recalled the previous thing that I typed in, is why I was able to why it looked like I just pressed a button on my calculator to get it in that moment there. Okay. So this is what I need you to be able to do from section 3. There's a lot of different ways that you can use matrices to solve a system. This is the fastest and the easiest and the most direct way to do it. This is the one that I'm going to use going forward when we have to solve systems as part of problems in section 4. Everybody's cool? Questions about how to do this? Do we feel all right doing this? Notice it's all on your calculator, right? There's not really any work to show. On a test or whatever, I would suggest showing me the matrix you typed into your calculator and showing me the matrix that comes out of your calculator and then telling me what the answers for the variables are. I would think is sufficient work. You know what I mean? Since the calculator is doing most of it. All right. So our last topic that we want to talk about in section 4 is called partial fractions. So the idea here is, let's say that we have some rational expression. So something like this. And we want to break it up into the sum or difference of fractions. So this is actually equal to that sum The question is, like, how did Mr. Kulik do this?
Oh, yeah, I was trying to figure out. I was like, what?
Not obvious at all how I would go about doing that. So this is what we're going to explain, is we're going to explain the process of how we could go about doing this sort of breaking everything up. Everybody's okay? All right. So our explanation here. The key is going to be looking at the denominator. the first thing I'd want to do is to factor the denominator. X squared minus 2x. How does that factor? It's the easiest Algebra 1-iest factoring that we ever do.
Oh, it's like the
It's not like the FOIL thing.
it's like x plus 1, x plus 2. Yeah, x plus 1, x plus 1.
No,
It's x minus 1, x minus 1.
no. I know you guys are. I know. How many terms do you have here?
2.
2. Is there anything in common between the two terms?
They got x's.
They both have x's.
So it's going to be x, parentheses, x minus 2.
Yeah, there you go.
Nice job.
Everybody's cool with that. So, as long as these factors, so we have 2 factors here in the denominator, are both degree 1 factors, like I just have 1x and I have just 1x minus 2, everything is pretty straightforward. We'll look at an example where we have maybe, multiple copies of one factor. So what that means is we're going to have something over x plus something over x minus 2. So whatever the factors were in the denominator are going to become the denominators of my sum. Is everybody okay with that? And if there's just one copy of each factor, like there was in this case where I had just 1x, right, an x to the first times a x minus 2 to the first, then there's just one of the fractions and everything is pretty simple. Cool? So if I were to then try to make a common denominator with these things, go ahead. I'd multiply this one by x minus 2 over x minus 2. And I'd multiply this one by x over x. So that's going to get me to here. Is everybody okay with how I went from that previous line to that line? When I made my common denominators? Are we cool or no? Do you need a minute to process? Any kind of feedback would be appreciated. Okay. If you don't got it, if you don't see it, say something. All right. So what I'm going to do is I want to take the parts in my numerator. Well, actually, hold on a second. Let's do this. Notice that now both of the sides, the denominator is the same, right? So I can forget about the denominator. That no longer matters to me. Okay, there. And what I'm going to do now is I'm going to take the x parts and group them together, and the constants parts and group those together. Is everybody all right with that? Okay, here's the trick. So if these two sides are equal, A plus B has to equal 3. And if these two sides are equal, negative 2A has to equal negative 4. Does everybody see that? And if both those two things have to be true at the same time, like they would in this problem, that creates a system of two equations. And we can solve that system any variety of ways, one of which could be using the matrix on our calculator. So I'll make a 2 by 3 matrix. My entries would be 1, 1, 3, negative 2, 0, negative 4. And then we'll do the RREF on that. So I get that A is 2 and B is 1. And now if we go all the way back to the very beginning of this problem, this implies that 3x minus 4 over x minus x, or sorry, x times x minus 2 is going to be 2 for my A plus 1 for my B.
Where did you pull those numbers from in the RREF?
So 1A, 1B. Is that cool? You guys want to do another example? Sure, right? Oh boy, do I really want to, how bad do I want to do this? Well, let's just do that. That's going to be the easiest way to do this. Some of the examples here are kind of nasty that we included in the notes because we wanted to do, like, make sure we did all the potentially complicated things. Let me just steal one of these guys. Yes, go right ahead. Let's do this. Okay. So let's take one of these. So the first step is to factor the denominator. Very good. How does this denominator factor? It's a difference of two squares. Great. So it's going to be
Plus 1 minus 1.
x plus 1, x minus 1.
Hopefully this is
Great. No, it's good. Shout them out if you know. So I can write then this would have been something over x plus 1 plus something else over x minus 1. Just FYI, this step is called like the partial fraction decomposition. I know that's a mouthful. Are we all okay? So the next thing I'm going to do is make a common denominator on that right-hand side. So what do I have to multiply the first fraction by? X minus 1. Everybody agree with that? And then what do I have to multiply the second fraction by? X plus 1, right? Are we okay with what I did there? I didn't show as quite as much work, but it's pretty trivial what I did, I hope. Should I write it in? There, we'll write it in. Okay, now that I've done this, what does that allow me to do? I can drop the denominators now, right? All that I care about are the numerator pieces. And when I do this, I also want to group the x parts together and the constant parts together. Everybody's okay so far? So notice here that I have x stuff on the right-hand side, but I have no x stuff on the left-hand side. Do you guys see that? Well, let's just put a 0x there. Now I have x stuff on the left-hand side without changing the value of the left-hand side, right? I should say correct. If I say left and right and then say right, it gets confusing. Okay, so let's set up our system. If I look at the systems, what does the x's say? I should write a plus b is equal to 0. Is the coefficient for x on the right-hand side should equal the coefficient for x on the left-hand side. Everybody good with that? Similarly, the constants on the right-hand side, negative a plus b, should equal the constant on the right-hand side, or the left-hand side, 4. There's my system. So when I do that, I get A is -2 and B is 2. So I can say then I had -2 over, shoot, I forget which one I wrote first, x plus 1 plus +2 over x minus 1. Leo, you're making a face.
Yeah.
Or did I?
Well, you can't like A be 0 but B be 4, but let's say A has a negative. So
That would satisfy the first or the second equation, but it wouldn't satisfy the first equation, right? So both equations have to be satisfied simultaneously. Is that less of a face now?
Yeah.
Okay. All right. Let's see how this changes if the degree on one of the factors isn't 1. Let's write it this way. First step. Uh-oh. Factor the denominator? How does this denominator factor?
You can do like an x 2
Great. And that leaves me with?
x plus 2.
Great. Notice here that we have a term that, or a factor that's not degree 1. Everybody see that? So here's the catch. You might think that we would just be able to do this. Just like we did last time? Nuh-uh. We also need a degree 1x. So for example, if I have some factor to the n, I'd have like a over f, b over f squared, c over f to the third, all the way out to, you know, you have to have one of everything. Is that, you kind of see what I'm saying there? So I won't give you many where that could happen. Or I certainly wouldn't give you one where like, oh yeah, we got like 6 of this one and like 5 of that one, and like it's a bonkers, like you have a gigantic system. Like, let's be clear, we're not going to have like, you know, like a 10 equation system kind of problem. 2 or 3 is as much as we're going to do. Okay. Yes? Okay? So far? Next step, we make our common denominator on the left-hand side here. What do I have to multiply this first fraction by? Anybody? I'm trying to get to x squared times x plus 2. I have an x squared. What do I need to multiply this by x plus 2 to the top and bottom. Okay. The next one, again, I'm trying to get x squared times x plus 2. Here I have an x. So what do I need to multiply this one by? Trying to get to x squared times x plus 2. I have just one x, so I'm going to need another x and also an x plus 2. And then what do I need to multiply the last one by? X squared. We doing okay? Is everybody okay how I multiplied everything out there and got my new numerator? All right. So here I'm going to group the x squareds together, the x's together, and then the constants together. So I can drop my denominators. And then I have b plus c x squared. And then I'll have a plus 2b times x plus 2a. Everybody good with how I did that? Now let's write this as a system. My first equation is going to come from my coefficients on the x squared. Notice there's no x squared on the other side. So I'm going to write 0a plus b plus c equals 0. Notice I put the 0a in there because I know that we have a, b's, and c's, so if I'm missing something, I'm just going to put a 0 there to save myself the aggravation a little bit later. My next equation, a plus 2b has to equal 4. Notice I'm missing a c, so I'll go ahead and write 0c when I get to the c spot. And the last one, 2a, should equal 4. So I'm missing b's and c's there. So there's my system. This is a pretty easy system to solve by hand if you so desire, but I'm just going to do these with my calculator because we're probably all a bit more comfortable doing it that way. What's up?
I keep, every time you do like the matrix button, can you like show me how to do the matrix button?
Yeah, so I'm just pressing second
Yeah.
and the x to the negative 1.
Probably fall like that.
Yeah, just to get some practice at it. Oops, where did that go? Ugh. What do we get? 2, 1, negative 1. So if we go back to our decomposition, we'd have 2 over x squared plus 1 over x plus negative 1 over x plus 2. So this is the most difficult skill that we do in this, I think, in chapter B. This is the last thing that we want to talk about. Why don't we got 30 minutes left. Why don't we try doing a couple of the problems that I assigned from this section? So why don't we do 63 here together? That was one of them that I assigned. So let's try doing that. So I'll give you guys some minutes. If you get stuck, feel free to ask a friend or go back and look at your notes or come talk to me. But we'll give you guys, I don't know, we'll give 5 minutes or something to whittle away at that. And if we still need more time after 5 minutes, we can take some more time. It's not a rush. Okay? And if you're planning to do the problem set, then you've already got like a start on some parts of it, right? Sound cool? Oops. Sure. All right, it's been 5 minutes or so here. So I wrote out what I did for this. Were you guys able to get that to go? All right, well, for next time, why don't you try to do the do those last couple. What do we have on there? 47, 50, so 63, 69, and 70. So try 69 and 70. And we can go through those next time. Sound good? Since this seems to be pretty significantly the most difficult thing that we do in this chapter. But this wraps it up. This is the last thing that we want to talk about. So Friday we'll talk about those last two homework problems doing the same task, and then we'll start our review stuff, okay?